more specific one. In this case, which one is more specific? X equals 0 is more specific. So that means I can now say x equals to 0, which means, well, we have done something, okay, but it doesn't really quite simplify the entire thing, okay, which is okay. Now we have post 2. Now this time it seems like, hey, this is easy because we know how to deal with this, right? X gets x plus 1, the right-hand side refers to the left-hand side, it's reversible. We can apply the substitution, inverse function, and all that stuff. So let's see how far that can get us. Okay, it can get us to a certain point. All right, so we'll go ahead and say, write all those statements. Okay, the right-hand side of line 2 refers to the left-hand side. Okay, the right-hand side of line 2, f of x, f of x is x plus 1 as an inverse. The inverse is f prime of x is x minus 1. That's how we inverse, add in 1. So use the substitution rule. We know how to use the substitution rule. Is substitution. Whatever is in pre-2, we want to replace all occurrences of x with the inverse function of f applied to x. That's the template. So we expand what is pre-2. You take this pre-2 here and go, okay, we'll just copy and paste it. Replace x with f prime applied to x, which is just saying x minus 1. And then we are stuck. We are stuck now because we can easily handle this one. That's not a problem. But we cannot handle this one. Right? Because that's the very same thing that we are trying to figure out now. Well, are you surprised that this might happen when we're dealing with a loop? This is the nature of a loop. All right, so what are we going to do in this case? What are we going to do with post 2? Well, post 2 has a very specific name because it is the one thing that is always there. Okay, it is there in the loop. It is there in the exit state, exit condition of the entire loop. It is called a loop invariant. Okay, loop invariant, as the name implies, means that this is the one thing that doesn't change, during all the iterations of the loop. Okay, this is the one thing that is always true, when you're in the loop and also when you're out of the loop. It is always true. Okay, so in this case, what are we going to do? Well, the exact technique to find out what is post 2 is not easy to explain. It just takes a lot of experience to deal with it. But I'll just say that well, okay, I'm just writing down the way I'm going to say it. Tech suspects that post 2 is x is less than or equal to 3. Okay, the less than or equal to part is important. Okay. How do we know that is right? Okay. What do you think?
You have to assume it's true and then try cases that will
Plugging in, right?
Yeah.
Now, if I think that post 2 is x is less than or equal to 3, then I can go back to this statement here, post 2 equals to da 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 da, and just plug in x is less than or equal to 3 here, and plug it in over here, and see whether it works out. Okay, so that's what we will do, and we have just enough time to do that too. Okay, so we'll just go ahead and work that out. So we'll say x is less than or equal to 3. Now this time I'm going to use equal and the question mark because we don't know whether they're the same or not. We're trying to prove that. Okay, so sub x is less than 3 and x is less than or equal to 3, and then we have extra parentheses for x equals to 0, x minus 1. All right. So the question is, well, are they really the same thing? Well, let's try to find out. So we'll say here is x minus 1 is less than 3, and x minus 1 is less than or equal to 3, or x minus 1 equals to 0. Right? Yep.
Can you put a couple spaces under it? So
Oh, scroll. Okay. Actually, what are we gonna do here? Let's see. X minus 1 is less than 3. What is another way to say this? Now, if I tell you x is an integer, is there another way to say this? Yep.
Can you say it's equal to or greater, or less than?
We can say that, right? Because if x is an integer, then to say that x minus 1 is less than 3 is really the same thing as x is less than or equal to 3. And then we have this one. Well, since we know how to deal with that one, we know how to deal with this one. We just add 1 to both sides, so it becomes 6, right? And then the one on the outside becomes x equals to 1. All right, it still doesn't, the left-hand side and the right-hand side still don't look the same. Well, we can simplify, can't we? Now, how do we simplify this? Okay, the first question is, if you look at this item here and this item here, do you think one implies the other one?
Yeah.
They seem similar enough that we can think that one can imply the other one. Which one implies which one?
X is less than or equal to 3.
X is less than or equal to 3 implies x is less than or equal to 4, but not the other way around, okay? Which one is more specific? X is less than or equal to 3 is more specific because it doesn't cover the case when x equals 4, right? This is a conjunction. We keep the more specific one. So that means this entire thing simplifies to x is less than or equal to 3. But wait, we still have some more here, okay? Now this is a disjunction. With a disjunction, do you think one implies the other one? Which way? Absolutely. X equals 1 implies x is less than or equal to 3. Which one is more specific? X equals 1 is more specific, but because this is a disjunction, we toss away the specific one because we want a more general one. Okay? So we keep the more general one, which is x is less than or equal to 3. Yay, Hack was right. Right? Because you just plug it in and see if it works out. Now, the fact that it does work out, now it has a little bit of Boolean algebra here, okay? Because all these derivation and simplification has to do with Boolean algebra. Yep.
Is that also that way because the only way you can ever get to post 2 is if x is less than or equal to 3. You can never get, if x was greater than 3, you wouldn't be able to get there.
Exactly.
Okay.
Yeah. So there are ways you can kind of try to figure out what post 2 may be. But knowing, if you have a suspicion of what post 2 may be, you can plug it in and see whether it works out or not. So that's the